Anyway, so in a number of areas, cancer, for instance, cytoxin, prednisone, adriamycin are used in human. All of those are used in the dog. And if you haven't already scanned all the way to the bottom, you'll see that the human and dog columns are identical. So the drugs that we actually use, the drugs that work, the drugs that have gone through testing, and in fact, in some cases, these studies were first tested in dogs, found to be safe, then used in humans, and the prediction was good. They worked in humans. And then the veterinary clinicians take that information on human dosing together with the original toxicity studies and use that as a way to determine the appropriate dose for the dog. And they use it on the dog. And in general, the same dose fits, the same kind of side effects are seen, and the same methods of controlling those side effects are used. So cancer, asthma, heart disease, kidney disease, liver disease, seizures, vomiting. I did not want to go beyond one slide, and I also didn't want to make the font too small, but the list could have been much longer. When you look at the medicines that are actually used on humans, the medicines that are actually used on animals, and this is true for the dog, and it's true for many species, they're very often the same. Another point I'd like to make is that in some cases they're very different. Don't give Tylenol to your cat. The cat metabolizes that in a very different way than the human does, and you can kill a cat. But there's an example of information that we've gathered that we use when we try to predict from one species to another species. So it's just as important to understand the differences as it is the similarities to be accurate in your predictions. Final thoughts? We have many safe drugs that have passed through a stage of animal testing. Different complex systems can have the same output. And by that I mean species, different species, even though at the biochemical level, the level of regulation of gene expression, even though they may be very different, can still end up looking very much the same and responding very much the same, having the same output to an insult, whether that's a disease or a toxic chemical. Mechanistic identity, in other words, one-to-one correspondence between a mouse and a human, for example, is not always required for us to be able to use animals in a way that's predictive. And finally, and here is where I would like to give my assignment to Ray for what he should talk about in his rebuttal. If animal models are abandoned, what will the study of disease look like? This is a critical question, and there are two ways in which I'd like the answer to that. And if he does not choose to address that now, I hope it comes up as a question, because this is an honest question. And I think it's a question that all of us have, regardless of whether we believe animals should be used or whether we believe they should not be used. How are we going to understand disease, particularly early stages of disease? One of the diseases I work with is pancreatic cancer. It's almost always identified in late stages. We really don't even understand the cell type of origin of pancreatic cancer. We're using animal models, we hope very effectively, to address that issue. But if we can't use those animal models, how are we going to find in a human population people with early stage disease? It's probably impossible. So how are we going to learn anything about the genesis of that disease? And finally, Dr. Greek focused a lot on how drugs would be screened and tested for effectiveness. And certainly that's a critically important issue, because that is one of the larger uses of animals. What are the options if we don't use animals? Not just for testing metabolism, not just for giving very small quantities and examining how they're metabolized in the human body, but for determining whether something actually has an effect, is efficacious, is therapeutic against a particular disease. And in particular, if humans are so different from each other that even identical twins respond differently, and if that means, according to the logic that Ray is using, that no human is predictive for another human, what will drug testing look like? I understand his notion about individualized medicine, and I expect that's where he will go. We can look at an individual and examine the metabolic pathways in that individual and target our therapies for that. Well, we're not at a stage where our basic understanding is good enough for that yet, but ultimately that is an objective that I think all of us would favor. It's also a rather elitist objective, because that's not something that we're going to be able to accomplish worldwide at this stage. I think, in fact, even in this country, it's not something that we can afford. So that's something I'd very much like to hear, and I think all of us would. What will be the face of research? How do we understand human disease? And what will be the face of pharmacology and toxicology? How will we find broadly active drugs that we can use across species safely and reproducibly? With that, I'd like to close, thanking you all again very much for attending. I think this is a very important issue. We've approached it in different ways, and I don't know about you, but I'm dying to stick around to see what happens next.
Thank you, Dr. Sandgren. And again, before Dr. Greek gets up here for this 5 minutes of rebuttal, if you have any questions, please pass them to the center aisle, and Susan, I think, is walking up the aisle now to collect them. Okay, Dr. Greek, your turn.
Well, number one, let me thank Eric again for that excellent presentation. I do have some disagreements, as should be expected, but it was an excellent presentation, and again, I thank you for being here this evening. I came here this evening to debate the predictive value of animal models, and I don't think that Eric came here to do that. I really don't think that this has been a debate as a debate is usually defined. In order to have a debate, both parties must address the same issue. Now, I've never said that using animals is useless, or that animals cannot be used successfully in various scientific endeavors, or that animals and humans don't have a lot of things in common. What I have said, and what I still maintain, is that the animal model, defined in just about any way you want to define it, is not predictive for drug testing and mechanisms of disease research. Now, I went to great lengths to define how the word prediction is used in science. And I will leave it up to you to judge who has presented data consistent with that definition. Now, what I would call the tactic that Eric used tonight is one that I'm somewhat familiar with. And there are people in the world who do a lot of debates. We have a lot of controversies going around creation evolution, global warming. There are people who don't think that HIV causes AIDS. And a lot of these people, when they get into a debate and they're faced with absolute facts that contradict their position, they use a form of bait and switch, okay? They change the conversation around so that instead of studying prediction as it is defined by science, for example, we can talk about how animals and humans did in fact react the same way to the same stimuli. We can cherry pick the data. Or we can talk about how examples from the past showed that animals and humans, again, did have things in common. We can discuss these topics at length, and they're worth talking about. But I think tonight we should have talked about prediction. Just saying that something predicted something carries no weight in science. You remember those slides that I showed about the drugs, the 6 drugs, and this many times the animal model matched, this many times it didn't. That's evidence. That's not anecdote. So the technique that I'm talking about was illustrated very nicely in the movie Thank You for Smoking. And it goes something like this. Yes, one can discuss, instead of the topic at hand, one can discuss something else and do a very nice job with it. and present very impressive data and very interesting data, but it's not about the topic. And so at the end of the lecture, you can leave your opponent, in this case me, shaking his head going, the audience really loved that talk, and they, thought it was fascinating, and they really liked you, but you didn't talk about the things that we were supposed to talk about. So I think that's a problem. To give a couple of examples where a certain animal species reacted similarly to humans, and from those limited examples to conclude that an animal model as a paradigm is predictive, is the fallacy of bloated conclusions. It would be like profiling several lottery winners and concluding that playing the lottery is the best way to save for retirement. It is simply misleading. I'll very briefly talk about Harry Harlow. Nobody in their right mind in the 1950s and 60s thought that ignoring babies was the proper way to raise them. Now, yes, there were a handful of scientists who were writing articles and books saying, yes, don't ignore the baby, don't hold the baby, don't go to the baby when the baby cries. Any mother of two with above a third grade education ignored that, okay? So there was not some vast scientific question hanging in the air that Harry Harlow addressed. That's just nonsense. So what will we do if we don't experiment on animals? There's 2 points to this. This is trephination. This is what we did in the old days, back when I was an intern, in order to expel the spirits from the person's head and thus curing them of schizophrenia, measles, the mumps, or whatever. We don't do trephination today, not because we don't have anything else to do, but because it just didn't work, okay? So before I talk about the proven methods that we should be using, if a modality is not predictive, then don't claim that it's predictive. Now, if you want to do other stuff with it, that's fine. But don't claim something that you cannot prove, especially in science. And what should we be doing today? Well, I'll tell you what we are doing today in about 1% of the cases. We are using DNA chips. If somebody has breast cancer, they're going to get genotyped, their cancer is going to get genotyped, and their treatment is going to be determined by that DNA chip. Okay? There are drugs today that we will give to certain people and will not give to certain people based on their genotype. And the only predictive ADMET testing, the only predictive modalities that we are going to have in the future are going to be your DNA. And that is where science is going. And if NIH funded personalized medicine, pharmacogenomics, and so forth, instead of funding animal models of Parkinson's, animal models of this, animal models of that, you would get to personalized medicine a lot sooner. And Eric, again, thank you very much for doing this. Appreciate it. Thank you, ladies and gentlemen.
Okay. Susan, you have questions? This has been extremely interesting. I agree. Second, the thanks. This one here. Oh, okay, I got you. Okay. Eric, we're going to start with you here as a question. Harry Harlow's studies may have been predictive, but were they necessary? Could we not have learned the same thing by studying, say, human orphans or babies who had been abused?
So the issue of looking back and determining whether or not a different method could have been used to identify certain pieces of information really, I don't think, is a very useful exercise. I can imagine that there could have been many different ways to identify that, but most of the scientific outcomes that we look back at could have been identified in many other ways. But they weren't. They were identified in a single way. So to answer the question, I suspect there would have been other ways to address those questions. But those were not the ones that were used. Those were not the ones that had the influence that they did. And in fact, the government was sending out pamphlets to people around the country telling them not to show affection, telling them not to touch their children. So it actually was a situation that existed in the society. It wasn't something that was so outlandish that no one believed it at all. So yes, other modalities could have been used, but in this case weren't.